Hey, and welcome to This Is My Architecture. My name is Peter, and I'm here with Lukasz from PGS Software. Hey, Lukasz, nice to have you here.
Hi, Peter. Thank you for having me.
Awesome. Lukasz, tell us a bit about your company.
PGS Software is a Poland-based company, which is advanced consulting partner. We are specializing in delivering custom-made solutions using cutting-edge technologies for our clients.
Interesting. So you guys are working on different projects, and you brought one of these projects with you today. What is it?
That's correct. So one of our customers approached us with the problem coming from the car manufacturers. The car manufacturers want to switch to just-in-time delivery to limit the cost of the warehousing. Typically, when they are ordering parts for the production line, it takes time because they have to go through several instances of the suppliers until it will end up on the final supplier. We were asked to build a cost-effective, performant, and resilient solution that will simplify that business process.
Interesting, quite a challenging requirement. So let's take a look at the board and walk us through.
Okay, so car manufacturer is producing an order file during the day. Typically, it's around 100, 200 files a day, which can contain multiple orders. We are gathering them on the OFTP server, which stores theirs and synchronize them to primary S3 bucket. What is important here, each file contains own unique ID, which is later on used for entire processing as a part of independency model. S3 produces an object-created event, which triggers the first Lambda function that we have written. That Lambda function is responsible for validation of the business file structure, orders, and pre-qualification of the content. Based on the input, it produces two outcomes. First one is the breakdown of the orders into separate files. The second one is a message stored in SQS for further processing and notification. Now, when the message is stored in SQS, that triggers another Lambda function called worker, responsible for entire business processing of the order. So how it's look like? We are pulling down information from Redis about supplier and car parts. And once the processing is successful, which means that all parts gathered for a certain supplier are gathered into a new file, which is prepared to send over to them, they are stored back again into S3.
All right, understood. So there's a flow, there's an interesting split in here. We can address this in a second. And there's a data retrieval from that Redis database. I assume this is kind of a mapping. So data comes from some other place.
That's correct.
That table.
Business people capable of matching the suppliers and registering them with internal system of car manufacturers are filling that up for us. And this is the information that worker is using for further processing.
Okay, cool. So it's there. The mapping happens. You store the outcome here in the S3, and I assume this goes out somewhere to an outgoing path, right?
That's correct.
Okay, interesting. Great. So, well, what happens if, because we're talking basically about a happy case, what happens if something goes wrong and there is no matching or whatever error happens during that flow?
Okay, so all Lambda functions implemented here are implemented according to reactive manifesto using backpressure, which means that whenever something fails, we are prepared for that and we are not keeping the state. In terms of the core heart, so worker logic, unknown suppliers, so those which are not referenced in the Redis table, are stored in separate new ordering file called unknown and saved into S3 bucket called erroneous. That triggers the retry logic.
Which happens here, I guess.
Yes. So let's go to the bottom one. Retry logic is basically triggered by CloudWatch scheduled events, and CloudWatch triggers two Lambda functions. First one, the notification one, is responsible purely for taking out the information about missing data and sending that in form of the email through the SNS further to
notify.
yeah, business people to escalate. The second Lambda function called repeater is there to actually take down the orders which are in unknown state and publish them once again into SQS. So by that, we are reusing entire flow in the same way, because if the supplier information is fulfilled, then worker will produce, again, valid messages.
Understood. This seems like a very solid solution, but in some ways it appears quite complex to me. We talked about the separation of the different flows here. You mentioned the repeater flow triggered by CloudWatch. Have you guys been thinking about maybe using step functions as an alternative?
Yes. At the beginning of the solution design, we were evaluating whether step functions for that workflow will suit better. But the initial requirements were around the performance, resiliency, and cost effectiveness. After initial calculations, it appeared that step functions will be 120 times more expensive than that implementation.
That's a factor.
Yeah, because you have to imagine that single order can contain up to 140 megabytes of data, which is translated into over 200,000 orders. Each of those single orders can contain thousands of parts to order from the suppliers, which overall for entire day of processing gives 22.5 billion of of the messages to be processed. Step functions is limited by the throttling and number of parallel executions. That's why it wasn't best fit here.
Absolutely making sense to go this way other than using step functions. All right, so did you guys think about any particular optimizations here? What's the next steps that you want to do in order to improve this even more?
Entire solution was built within 4 weeks, and certainly it got some improvements to be made. First of them is to actually replace that part connected with OFTP and S3 events to something much more resilient and persistent. For example, put here instead of S3 event SQS bus to have that persistence over messages. Second thing, because we are storing the raw data about orders and how the processing looks like, this is a perfect entry point for big data solution. So we've got data lake in place, and we can extend that easily for the business.
Okay, so in order to do another or additional analysis and get some more information out here. Very interesting. Lukasz, I have to thank you very much for this introduction.
Thank you.
And thank you for watching This is Smart Architecture.